Alright, this video is section 5.6a, which is finding rational zeros from Algebra 2. First thing we're going to talk about is the rational zero theorem. What you're going to hear about this from now on is going to be called your P's over your Q's. And really what your P's over your Q's is talking about, so P's over Q's, is our factor, a factor of a sub 0 over a factor of our leading coefficient. So what that means really is we're looking at our a sub n on that version. So we're looking at a sub 0 on the top for our p's and a sub n for our q's. All right, so what does that really mean? I know that looks like gibberish. So what we're going to do is let's look at an example. Our p's and our q's. So our p's, what we're going to look at is we're going to look at our constant number. And we're going to look at all the numbers that multiply to get us 12. Well, I know that 1 times 12 gets us 12. I know that 2 times 6 gets us 12. I know that 3 times 4 gets us 12. And that's all of my possible factors that'll get me 12. But here's the trick. Here's the catch. I can also do negative 1 times negative 12. I can do negative 2 times negative 6. I can do negative 3 times negative 4 to get positive 12. So really, we're going to be looking at the positive or negative of each of these. So plus or minus, plus or minus, plus or minus. So our p's are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Our q's, we're going to look at our leading coefficient. And our leading coefficient in this instant is 1. In this instance. So our q's, really, it's just going to be 1 times 1, right? But again, it can be negative 1 or positive 1. Because we can do negative 1 times negative 1, positive 1 times positive 1. Those are our p's and our q's. So now we have to look at our possible p's over q's. And the way we're going to do that is, really, it can be positive or negative 1 over positive or negative or 1. So it's really positive or negative 1. Positive or negative 2 over positive or negative 1. Well, that's really just going to be positive or negative 2. Positive or negative 3, positive or negative 4, positive or negative 6, positive negative 12. So if you look, these are all of our possible solutions. So really, it looks like we only have 1, 2, 3, 4, 5, 6 solutions. 1, 2, 3, 4, 6, or 12. But really, it's 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, 6, negative 6, 12, negative 12. So really, we have 12 different possible solutions right there. All right, let's look at another example here where we're not given a 1 for our q's. So our p's, again, our p's, we're going to look at this negative 6. But remember, we're going to do positive or negative for all of them. So it's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are all my possible numbers that'll get me multiplied to get negative 6. Now we're going to look at our leading coefficient, which in this case is 2, so our q's. Well, really, we're going to have plus or minus 1 or plus or minus 2. Now is where things get tricky here, get trickier, I should say, for my p's over my q's. Really, what we're going to have is we're going to take our plus or minus 1 over plus or minus 1, plus or minus 1 over plus or minus 2, plus or minus 2 over plus or minus 1, plus or minus 2 over plus or minus 2, plus or minus 3 over plus or minus 1, plus or minus 3 over plus or minus 2, plus or minus 6 over plus or minus 1, and then plus or minus 6 over plus or minus 2. Well, now we have to go and cancel out the ones that we already doubled up on. And really, we're only going to list them once. So our p's over our q's. Plus or minus 1 over plus or minus 1, that really just becomes plus or minus 1. Plus or minus 1 over plus or minus 2 is really the same thing as plus or minus 1/2. Plus or minus 2 over plus or minus 1, well, that really just becomes plus or minus 2. Plus or minus 2 over plus or minus 2, that's plus or minus 1, but oh, we already have that listed, so we don't need to list that one again. Plus or minus 3 over plus or minus 1, plus or minus 3 over plus or minus 2, so plus or minus 3/2, plus or minus 6 over plus or minus 1, and then plus or minus 6 over plus or minus 2, that becomes plus or minus 3. Oh, we already have that. Don't need it again. So here are all of my possible zeros, my possible rational zeros for that problem. All right, I want you guys to do this last one on your own. I'll put up the answer in 1 second. All right, so in the green there, that's what I got for my possible rational zeros. Now, some of your teachers might make you guys write these in order, so make sure you check with your teacher if they want you to write in order from biggest to smallest. I kind of just let them list it out however you guys got to do it. Now, some of you guys are going to say, do I really have to list out every single one like you did in the black? The answer is no. I mean, I personally don't say so. Some teachers might say so. I would say only do the black step if you need to do that step. All right, now we're going to talk about a little bit about end behavior, remembering that with positive leading coefficient and a negative leading coefficient, you're going to get different things. So when we have an even graph with a positive leading coefficient, that means we're going to end up going towards infinity both ways. So an example would be a fourth root or a fourth power would look something like that. Let me redraw that so it looks better. So if I have a fourth power, it's going to look something like that, where they both end up, going up. So it's facing up. When it's a negative leading coefficient, it's going to be the opposite. So if I do a sixth power here, it's going to end up down. So both of them are going to be down. So even powers, when it's positive, they're both going to end up going up. When it's negative, they're both going to end up going down. Now it gets a little bit different when we're talking about odd powered graphs. When I have a positive leading coefficient in an odd power graph, we're going to go and we're going to start down and then we're going to end up. So here's a third power. We're starting down, ending up. When we have a negative leading coefficient, we're going to do the opposite of that. So we're going to start up and we're going to end down. So if I have a fifth power, I keep saying root, I meant fifth power, I'm going to start up, end down. Negative, start up, end down. Positive, start down, end up. You're going to need to make sure you know how to do that for the next section. But first, let's go and let's talk about finding the possible rational zeros and then factoring it from there. So, again, finding possible rational zeros, that's our p's over our q's. So we have to find our p's, and then we have to find our q's, and then we have to actually do our p's over q's. So I'm going to do that really quick. All right, and there are my p's over q's, and I'm going to get rid of those in a second. I'm going to get rid of the blue and the red. Just wanted to show my steps before I got rid of that, because now I'm going to need space. So what we're going to do now is we're going to find the actual factors that work for this. And the way we're going to do this is we're going to use synthetic division. So we're going to use synthetic division, and I'm going to go up here and I'm going to fill in what I know. Well, I know it's our highest degree is 3, so I'm going to count down, remember. And our leading coefficient is 1. The second degree is -8. Our first degree is +11 for the coefficient. And our 0th degree is +20. All right, now what we have to do is we have to, and remember we always bring that down, we need to find where we get a 0 in that last box there. So in that last box, we need a 0. And where are we going to get the numbers that we put outside? Right up here. Our p's over q's. We have to kind of guess and check which one's going to work. I personally always like to start with 1, so let's try +1, see if it works. So 1 times 1 is 1, add those up, we get -7, we get -7 there, -4, 1 times -4 is -4. If you look at that, that's not going to work. So -1 doesn't work. So what should we try now? Again, I'm just going to keep going up, I'm going to try -1. So -1 times 1 is -1. Add those up, we get -9. Add those up, multiply, we get +9. Add those, we get 20. -1 times 20 is -20. Look at that, we end up with 0, and that's exactly what we wanted. So right now, we know a factor of that f of x is x plus 1, because it's the opposite, remember, of this. And then we fill in these parts for our second part, so we get x squared minus 9x plus 20. So now our last step is going to be to factor that last piece there. F of x is going to equal x plus 1 times x minus 5, x minus 4. So that's that's our fully factored version, which means we can also find our zeros because x is going to equal -1, 5, or 4. These are all of our zeros, and if you look, they should be up in our possible zeros, which they all are. And what that actually gives you is the zeros on the graph where this graph crosses the x-axis. And I'll show you that more in the next video. But let's go ahead and let's do this next problem. So again, we need to find all the possible rational zeros, our p's over q's, which I'm going to put up here. So there's all of our possible p's over q's. Now we're going to have to go and we're going to have to do our synthetic division, so let's set that up. Remembering to skip that x squared, putting a 0 there, not just skipping that part. And we need to make sure we get a 0 for our remainder in order for it to be a factor. So again, let's start with 1. Let's try it. So 1 times 2 is 2, get negative 5. 1 times negative 5 is negative 5. Add those, we get negative 5. 1 times negative 5 is negative 5. That one doesn't work. So again, I like to just keep going in order. So negative 1. So negative 1 times 2 is negative 2. Negative 9. We get positive 9. Add those, we get 9. Negative 1 times negative 9 is negative 9. Look at that. They add up to get us 0. So again, we know if one of our factors of this problem is x plus 1. So f of x equals x plus 1. Then we bring down our new factored version here, 2x squared minus 9x plus 9. Now we need to factor that completely, which I'm going to forget about that x plus 1 for a little bit and factor by grouping here. 2x squared minus 6x minus 3x plus 9, because we need to multiply what multiplies to positive 18 but adds to get you negative 9. Well, negative 6 and negative 3, so then we get 2x times x minus 3 minus 3 times x minus 3. So really, we end up with down here is x minus 3 times 2x minus 3. Now I'm going to bring down that x plus 1, and that's going to equal f of x. That's our fully factored version. And again, we could go find our zeros in this part here. So we would get x equals negative 1, 3, or positive 3 halves. Again, look up in our possible rational zeros, and they all are there, which means we did that right. That's all I'm going to talk about in this first video. Make sure you guys watch the next video to take it the next step where we actually start graphing these.